In this sequence of videos, we're going to discuss the graphs of the sine and cosine functions. Now, whenever you have a function that is relatively new and you want to sketch the graph of it, a reasonable thing to do is to create a table of the inputs and the outputs of that function. So that's exactly what I'm going to do, and what I'll need in order to do this is a reasonable unit circle. So here I have a unit circle where I've only marked the quadrantal angles, 0, pi over 2, pi, and 3 pi over 2, and the angles that are halfway in between each quadrantal angle. And I've also marked the terminal point for each one beside the angle value. So I'm going to create a table of values to sketch a graph, and I'm going to use these t-values to create my table. So I'll create my table on the next page because there's no room on the previous page. That's also why I did not include the other angles, the other special angles that we know on the unit circle, because, well, it's just a bit too much. If you would like, in any textbook, you're going to find a much prettier drawing than I'm going to draw right here. They'll include all of the angles that we know on the unit circle. But you don't need all of the angles on the unit circle to get a rough sketch. So here I have a table. I'm going to include a table for both sine t and cosine t, and then we'll draw a sketch resulting from this table. So the first t value here is t equals 0. And for t equals 0, cosine is 1. So at t equals 0, cosine of t is 1, and sine of t is 0. Then the next value of t is pi over 4. So at t equals pi over 4, sine of t and cosine of t are equal. They're both root 2 over 2. And I'm going to go ahead and fill this in relatively quickly at this point. So we have pi over 2, we need 3 pi over 4, we need pi, we need 5 pi over 4, we need 3 pi over 2, we need 7 pi over 4, and we need 2 pi. And let's go ahead and get some dividers. And all I've done is I've just included the t-values that are on this unit circle that I've drawn so far. So at pi over 2, sine of t is 1 and cosine of t is 0. So 1, 0. And we could keep on going back to the unit circle to figure all these out, but I know what they are, so I'm going to fill this in relatively quickly. So root 2 over 2, negative root 2 over 2, then 0 minus 1. Then at 5 pi over 4, both sine and cosine are minus root 2 over 2. Then at 3 pi over 2, sine is negative 1 and cosine is 0. Now at 7 pi over 4, sine of t is minus root 2 over 2, and cosine of t is positive root 2 over 2. And then finally, at 2 pi, sine is 0, and cosine is 1. And it will be useful to have a decimal estimation on root 2 over 2, since we're going to have to graph this in order to get a visualization. This is approximately 0.707. And by that same logic, you might think that we need to get a decimal representation for things like pi over 4, pi over 2, etc. But our t-axis, as you'll see, is going to be in terms of pi, and we won't actually need those approximations. You'll see in a moment. So now I'm going to go ahead and create my axes. So there's my y-axis, and this will be my t-axis. So here's t, y, And I'm going to give myself a fair amount of room in the y direction so we can see the graph clearly. So I'm going to actually make this 1, and then I'll do the same in the negative direction. And since root 2 over 2 is about 0.707, I'm going to make a little mark a little less than 3/4 of the way, because 3/4 of the way is 0.75. So that way I know I have an approximation here for root 2 over 2, which I'll need quite frequently. And I'll make a similar mark in the positive direction. So that's about negative root 2 over 2. This is root 2 over 2. And now in the t direction, the way that I'm going to do my scaling is I'm going to make this here pi over 4. It's very, very common to have your scaling in the t direction when you're graphing trigonometric functions to be some multiples of pi. So then this would be pi over 2, and actually I'm going to label pi over 2, not pi over 4. I can't label everything because I don't have infinite room here. So I'm going to label pi over 2 pi, and then I'm going to label 3 pi over 2, and then finally, looks like I go a little bit beyond where my arrow is, but that's okay. This will be 2 pi. And then I went ahead and cleaned this up a little bit so it doesn't look too terrible. And now we're in a position where we can start sketching our graph. So I'm going to start with sine of t. So I'll go ahead and look at sine of t. It goes from 0 to root 2 over 2 to 1. So it starts at 0. Then at pi over 4, it's root 2 over 2. Then at pi over 2, it's 1. Then it goes pi over 2, 0, then it goes root 2 over 2, 0, minus root 2 over 2, minus 1. So again, root 2 over 2, 0, then negative root 2 over 2, and then negative 1. And then it goes back to minus root 2 over 2, and then to 0. And of course, you can actually sketch more points if you include things like pi over 3 and pi over 6 in your table, and the angles in the other quadrants will have reference angles equal to pi over 3 and pi over 6, but it's not necessary to get a sketch. And as you can see, I'm already pressed for room when I'm listing this table here, so I just won't include those. But if you look in the book again, you can see a better, not a better picture, but a, let's say, more detailed. So then I'll go ahead and connect these, and we'll get the trigonometric graph sine of t, or a sketch of it at least. And there we go. And now I think it's worth it at this point to go ahead and make some remarks. So what if we wanted to sketch more of this? Well, then we would have to continue moving along the unit circle. Essentially what we did is we started at t equals 0, and we went all the way around the unit circle, recording these points, or recording these angles and their terminal points, and then we ended back where we started. But if we wanted to sketch more, we could continue moving along, and we'd actually just be sketching the exact same points again. And so the result of that would be that if we continued along the way, then we would sketch the same shape, and this would end here at 4 pi. And you could continue again around the unit circle and get more of the graph. But what's going to happen is this is just going to repeat. This shape is just going to repeat over and over again. Similarly, if you wanted to go and get some negative angles and sketch what the graph is for negative angles, you'd get something that looks like this. do a little bit better, where this here would be negative 2 pi. And so quite literally, this graph just repeats over and over and over again. However, usually when one sketches the graph of a trigonometric function, they only include up to when the graph starts repeating. Sometimes an additional repeat is drawn, but at some point you have to stop, right? You can't draw every repetition of this graph, and so usually one is sufficient. Let's sketch cosine of t. So cosine of t starts at 1, then goes to root 2 over 2, then 0. So 1, root 2 over 2, 0. Then goes to, you can take a look and verify this on the table, but I'll sketch it very quickly. It goes to negative root 2 over 2, negative 1. Negative 1 has to happen at pi, though. Then negative root 2 over 2. Then it goes back to 0, goes to root 2 over 2, and then back up to 1. And a sketch would look like this. Connect these with a smooth curve. There we go. And similarly, if you wanted to sketch more of this, you could. You just would repeat this behavior, and then this t-value over here where you stopped repeating is going to be 4 pi, and if you did another repetition, that would end at 6 pi. And if you went backwards, then you would end here at negative 2 pi, etc. Quite literally copying and pasting over and over again the shape of this graph. What I've done here is I've sketched one period. So let's go ahead and write that. I have sketched one period of sine of t and cosine t. And remember, the period of sine of t and cosine of t, that's equal to 2 pi. So what I'm saying is that I've sketched part of the graph where this length here is 2 pi. So this visually describes what the period of a function is. So not all functions have this characteristic that they repeat over and over again, but the ones that do are called periodic. And the length in the x value that it takes for them to repeat is called the period. And more specifically, the smallest length that it takes for a function to repeat itself is called the period. Mathematically, I would say that sine of t is periodic with period 2 pi, and the reason being is since sine of t plus 2 pi equals sine t for all t. And then there's this technical detail that you can't find a smaller thing to add to t. That is, this 2 pi is the smallest positive number that you can add to t, such that sine of t plus that number is sine of t. That last point is pretty technical. What's extremely important is that you understand that sine of t plus 2 pi is the same thing as sine of t for every t. And it's fairly easy to understand the reasoning. If you go back to this unit circle and you pick any point on the unit circle, then this here is some angle t, and it has a terminal point, x comma y. And if you go another revolution around the unit circle, then that angle would be t plus 2 pi, but the x and y coordinate would be the same. And so the sine of t, that is the y coordinate, is the same as the sine of t plus 2 pi here, because you ended at the same terminal point. You may be thinking to yourself, well, okay, sine of t is periodic with period 2 pi. What about cosine of t? And for the same reasons, cosine of t is also a periodic function. So we could write the same sentence. Cosine t is a periodic, oh, I did not write function. This should say a periodic function with period 2 pi, since cosine of t plus 2 pi is the same as cosine of t for all t. And finally, I'll go ahead and remind you about the domains and ranges of these functions. So you can take any value of t and put it into the sine or cosine function, and that means that the domain of sine t and cosine t is minus infinity, comma infinity. So the domain of both of them is all real numbers. And now if you want to know the range, you'll see that both the sine t and cosine t function are trapped between -1 and 1. Their y values never get larger than 1, and they never get smaller than -1. And for that reason, the range of both of these functions, sine of t and cosine t, is -1, 1.